What's up, everyone? Here we are in week 3, and just some quick announcements. Last week was a lot, but you guys really delivered for the most part, and I'm really proud of you for that. And we've crushed it now for months on end, in my opinion. I think the class is going super well. So I've decided that this is going to be chill week, and that's just because we're going to do a 1 week unit that is really easy in my opinion. It's still AP stuff, but it's almost like it's common sense. Also really enjoyable. So we're just going to do 2 problem sets this week covering what's called two-way tables, and it's going to kind of expand upon what we just did with scatter plots a bit. And then after that, we're going to go into probability for the next 5 or so weeks. So this week hopefully will be really relaxed, and I'm hoping this is like a good lesson too, not too long of a lesson, and an interesting one. But yeah. First, like, you might see this and be intimidated because I threw in some like Google Sheets stuff, but I'm just showing you this because I want to show you exactly what's happening. And if this lesson is really easy, that means that we have some time to really understand the logic of it, right? So the gist of what we're doing today is we're returning to categorical data, which we only covered in the first lesson of the whole year. And what we've done this year so far is we've taken quantitative data sets, right? So something like the number of hours of sleep each student has or something like that. And the first unit we had a single quantitative data set. The second unit we had 2 quantitative data sets. But now we want to talk about what we do with categorical data. Okay, because even though, so like if we're looking at this, imagine that I surveyed students along 3 variables, right? The hours of sleep they had, their academy, and what gender they identify with. And just because these 2 variables are categorical and not numerical, doesn't mean that we can't actually do statistics for them. So I remember telling you in the beginning of the year, like, there's a lot less we can do with categorical data. We can't find the mean, the median, anything like that. But we're going to expand today on what we can do with it. And it's really easy. The first thing is review. It says to create a relative frequency chart for the academy data. And what I want you to remember from the very beginning of the year is that the best way to take a data set and organize it is to make a table or a chart, right? So if you have categorical data, the chart that we created in the beginning of the year that you can still create, has every category, which in this case are the 3 academies, and then their frequency, which is the number, and their relative frequency, which is the percent. So I listed my academies, and if I wanted to make a frequency chart, and my handwriting looks terrible, but whatever, all I have to do is count how many people are in each academy, right? So this is kind of just a cross-out method. You could use tallies if you wanted to, but I'm just going to do it. But you count each one, and if we add law for the first, cross it out, we're just trying to find how many students are in each academy. So you can just see, I'm just going to put the answer up. So you count them all up, we find that there's 11 students in Law Academy, 12 in Engineering, and 7 in Health. But the other thing that we've learned to do is the relative frequency, which is just the percent. So if I wanted to find the relative frequencies, I have to have my total, and that total becomes more and more useful as today goes on. But it's going to be 11 divided by 30 all the way down. And then it always will add up to 100% or 1. So remember, that's the first unit. But what we're trying to figure out today, the big gist of today, is that we're going to now have 2 variable categorical data sets. Okay, so that's like a really logical flow of things, right? We had a quantitative data set, a single set, and then a double set. We've done categorical with a single set. Now we want to figure out what we do if we have 2 categorical data sets. And this is not going to be relevant at all. We're just looking at these 2 data. And the first thing, just like making a scatter plot as the beginning of last unit, is we want to figure out how to organize this data. And the big idea here, and I think this is really, really interesting, is all we're going to do is expand upon this graph or this table that we just made. Okay, so instead of talking about frequencies and relative frequencies, from now on we're only going to deal with frequencies. But we know that of the Law Academy students, there were 11 of them, we could split that up into gender, right? Boy and girl. So we could have a row that's boy and a row that's girl, and that's going to tell us a lot of information. We can split up all of my frequencies by a second variable. Okay? So let me show you. So we have my 3 academies, and that would be going down. But actually, we don't even want to put this here, because instead of frequency and relative frequency, we're just going to split my data into boys and girls. And hopefully that makes sense to everyone, and hopefully everyone's like, okay, this is really easy and obvious. But all a two-way table does, if you start seeing variables both directions, so not frequency, which just measures one variable, but you see actual variables on both sides, that means that you have 2 sets of categorical data. Okay? And to count this, all I have to do is look for how many were law and then a boy, and that would be 1, 2, 3, 4, and keep going like that. Okay, so I'm going to fill this table out, but that's what a two-way table is, and that's what we're going to be looking at for the rest of this, even though I'm probably not going to make you create any more of them. Okay, so that's if you count them all up, but you have to make sure you include the totals, because this whole unit is going to deal with percents or proportions quite a bit, so we want to make sure that we have those totals. So all I'm doing is adding this way, 11, which was the total frequency of law, and then if I add down, it's going to tell you how many boys were surveyed and how many girls were surveyed. Okay, so that's creation of this chart, and the rest of this is going to be about 2 new vocab words that are both really easy and opposites of each other, which are association and independence. So what C says is joining the Health Academy independent of gender? And this is the kind of phrasing you're going to see quite a bit, and I think it makes a decent amount of sense in this context, but it doesn't always make a lot of sense when you read it. But it's asking us if joining the Health Academy is independent of gender. And what independent means is that it doesn't matter if you identify as a girl or a boy, you're going to join the Health Academy at the exact same rate. Okay? So the key to this is to figure out what we're talking about. We're talking about joining the Health Academy, which is this row. So I'm always going to recommend you circle the row. And it's talking about joining the Health Academy and if it's independent of gender. So the way that we find that is we see, is the percent of boys who joins the Health Academy equal to the percent of girls that join the Health Academy? Okay, because if that percentage is the same, then we know that boys and girls are joining the Health Academy at the exact same rate. And it's important that we're doing this divided by this, because it's going to say that, you know, of the boys, they have a choice to make what academy to join, but the same percent of boys make the choice to join Health Academy as girls. So I'm going to do equals that for the first percent, and then that for the second percent. Okay, so we calculated these percents, which is really easy to do, and what it tells us is 23% of the boys and 23% of the girls are sign up or are part of the Health Academy. So even though these percentages are a little different, this is going to show independence, right? If we saw a huge difference between the two percentages, that would indicate that one gender really preferred an academy compared to the other. But this is saying that guys and girls both choose to join the Health Academy at the same rate. And that's what independence means. I'm not even sure if I explained it that well, but it's really easy, so we're going to do a few and it'll make sense by the end. But now it's the opposite. It says, is there an association between joining the Engineering Academy and gender? So now it's asking us, is there an association between the Engineering Academy and gender? And the key always is find your percentages first, okay? And because we're talking about the Engineering Academy, comparing the boys versus the girls, we're going to do this divided by this, and then this divided by this. Okay, and then once we do that, we'll kind of explain why. Okay, So we found those 2%, and we found that of the 13 boys, 46% of them were in engineering, and of the girls, 35% were in engineering. So even though they had the same number, we have to remember that that number doesn't matter without the context, and the context is always the total. So a way higher percent of the boys join the engineering academy. So that is what we call an association. Okay? So if the percentages are equal or very close, and very close is 1%, right? They're both in the 23s, so that counts as independence. But if the percentages are way different, that tells us that one of our two, in this case the boys, are way more likely to join engineering. So that's an association, right? Boys are more associated with engineering than girls. So hopefully we see the difference between them, and then, yeah. I'm gonna give myself like a C- for my explanation today, but it's okay, it's chill week. For E it says, is identifying as a boy independent of academy affiliation? This hopefully will tie it all together. And what's worded different here is that the first thing that it tells us is boy, and then it says, is boy independent of academy affiliation? And what you need to realize is that every question is going to either point to one of these or one of these. It's going to point to one of the specific components of one of your variables. And in this case, it's the boys. We're talking about the boys. I didn't mean that in some cheesy the boys thing, but yeah. And it wants to compare the boys by their academy affiliation. So every question will tell you basically what to circle in the question, and you're comparing it along all the different academies. So if they're independent, all of these percents are going to be the same. So you can have multiple percents, but we'll just see how it goes. So yeah, because these percentages are way different, it's not independent. And if it was independent, they would all be the same. Okay, so there is an association between identifying as a boy and what academy you join. Okay, so we're here for our second example, and I think this example is pretty fun and hopefully makes everything make sense. And what you're going to notice is that sometimes from me or from other people like the AP, you might be asked to fill out a chart that has blank answers, okay? And to fill out those blanks, you're going to have to use logic. And usually that's just going to relate to independence. So this is just going to push what we know about independence versus association. And the gist of this two-way table is it talks about every student's grade level and how they get to school. And to help fill out these 4 blanks, it tells us that biking to school is independent of grade level. And the key to that is that if we know that biking is independent, we're going to be able to fill out the entire biking chart, or sorry, the column or row. And the reason is, what independence means is that the percent of all grades who bike is the same. So if like 10% of my 9th graders bike to school, that means that 10% of my 12th graders also bike to school. So what I believe is the hardest part of this by far, sometimes, is knowing what to divide by. But if you can really understand what independence means, you're going to be able to figure out what to divide by. So if it says biking is independent of grade level, we know that every biking divided by total should be the same, right? Because each grade should have an equal percent of students who bike. So all we have to do is figure out that percent, right? So we actually have 2 options here. We have 6 divided by 80, which is 0.075. And just to check, we could do 8 divided by 107, which is 0.0747. So whenever you have percents that are that close, we know that that means that they're independent. So for every grade to be independent, all of these percents have to be 7.5%. Okay, and using some quick logic, the way that you can find that is just by multiplying 0.075 to 67. And we get 5.025. And again, let me just tell you how I did that, like why that logic works. We know that the percent of 9th graders who walk to school is 7%, and there's 67 total. So if I want to get x by itself and figure out what this is, I just have to move 60 to the other side. 67. And here, and this doesn't always happen, but if you see a number that's not rounded, round it. And this is clearly 5. Because if 5 out of 67 9th graders bike to school, that's like 7.5%. So I can do the same thing for here. We know that x over 93 equals 0.075. So let me just multiply those two together. And I don't know, it took me a little bit to get into this lesson, but I think it makes sense, right? And then finally, know that you might have some other random blanks. And if you have other random blanks, fill them out after you fill out like whatever's independent. Because this and this, all we have to do is realize that if there's 67 students and we've accounted for 37 here, that there's 30 left, right? Because this plus this plus this plus this, that's what the total is. So here we could do the same thing, 18 plus 34, 52 minus 93, and I think that's 41. I'm just going to confirm, but I'm a math teacher. So yeah, that's how we do that. Cool. Alrighty, so that's that. Hopefully I edit it down so it's not too long of a video. And then the questions we do should be really, really easy after that. So if the lesson left you feeling a little bit confused, don't worry, it's chill week and the question is going to be easy. Woo-woo.